Good morning everyone. Myself I am G. Likta from CSIT. Today's my topic is desertification. Let's start with the introduction of the topic. Desertification is a type of land degradation in dry lands in which biological productivity is lost due to natural processes or induced by human activities, whereby fertile areas become increasingly arid. It is the spread of arid areas caused by a variety of factors such as climate change and overexploitation of soil as a result of human activity. Throughout geological history, the development of deserts has occurred naturally. In recent times, the potential influences of human activity, improper land management, deforestation, and climate change on desertification is the subject of many scientific investigations. As recently as 2005, considerable controversy existed over the proper definition of the term desertification. Helmut Gist 2005 identified more than 100 formal definitions. The most widely accepted of these was that of the Princeton University Dictionary, which was defined as the process of fertile land transforming into desert typically as a result of deforestation, drought, or improper agriculture. However, the original understanding that desertification involved the physical expansion of deserts has been rejected as the concept has evolved. Desertification has been defined in the text of the United Nations Convention to Combat Desertification as land degradation in arid, semi-arid, and dry subhumid regions resulting from various factors including climatic variations and human activities. There exists also controversy around the subgrouping of types of desertification, including, for example, the validity and usefulness of such terms called man-made and non-pattern desert. Let's see the history of the topic. The world's most noted deserts have been formed by natural processes interacting over long intervals of time. During most of these times, deserts have grown and shrunk independent of human activities. Paleo deserts are large sand seas now inactive because they are stabilized by vegetation, some extending beyond the present margins of core deserts, such as the Sahara, the largest hot desert. Historical evidence shows that the serious and extensive land destruction occurring several countries ago in arid regions had three epicenters: the Mediterranean, the Mesopotamian Valley, and Loess Plateau of China, where population was dense. The earliest known discussion of the topic arose soon after the French colonization of West Africa when the Comet de Etudes commissioned a study of descent progress if to explore the prehistoric expansion of the Sahara Desert. Let's see what are the areas affected by it. Drylands occupy approximately 40 to 41% of Earth's land area and are home to more than 2 billion people. It has been estimated that some 10 to 20% of drylands are already degraded, the total area affected by desertification being between 6 and 12 million square kilometers, that about 1 to 6% of the inhabitants of drylands live in desertified areas and that a billion people are under threat from further desertification. As of 1998, the then current degree of southward expansion of the Sahara was not well known due to lack of recent measurable expansion of the desert into the Sahel at the time. The impact of global warming and human activities are present in the Sahel. In this area, the level of desertification is very high compared to the other areas in the world. All areas situated in the eastern part of Africa, that is in the Sahel region, are characterized by a dry climate, hot temperature and low rainfall, that is up to 300 to 750 millimeters rainfall per year. So droughts are the major in this Sahel region. Some studies have shown that the Africa has lost approximately 650,000 people productive agricultural land over the past 50 years. The propagation of desertification is considerable. The climate of the Sahara has undergone enormous variations over the last few 100,000 years, oscillating between wet grassland and dry desert every 20,000 years. A phenomena believed to be caused by long-term changes in North Africa climate cycle that alters the path of the North Africa monsoon, caused by approximately 40,000 year cycle in which the axial tilt of the Earth changes between 22 degrees and 24.5 degrees. Some statistics have shown that since 1900, the Sahara has expanded by 250 kilometers to the south over a stretch of land from west to east 6,000 kilometers long. The survey done by the Research Institute for Development had demonstrated that this means dryness is spreading fast in Sahelian countries. 70% of the arid areas has deteriorated and water resources have disappeared, leading to soil degradation. The loss of topsoil means that plants cannot take root firmly and can be uprooted by torrential water or strong winds. The United Nations Convention (UNC) says that about 6 million Sahelian citizens would have to give up desertification zones of Sub-Saharan Africa for North Africa and Europe between 1997 and 2020. Lake Chad, located in the Sahel region, has been hit particularly hard by this phenomenon. The cause of the lake drying up is due to irrigation withdrawal and the annual rainfall dropping. The lake has shrunk by over 90% since 1987, displacing millions of inhabitants, and managed to make some process or progress towards its restoration, but it is still considered to be disappearing entirely. Let's see the effect of desertification. First one, sand and dust storms. There has been a 25% increase in global annual dust emissions between the late 19th century to present day. The increase of desertification has also increased the amount of loose sand and dust that the wind can pick up, ultimately resulting in a storm. For example, dust storms in the Middle East are becoming more frequent and intense in recent years because long-term reductions in rainfall promoting lower soil moisture and vegetative cover. Dust storms can contribute to certain respiratory disorders such as pneumonia, skin irritation, asthma, and many more. They can pollute open water, reduce the effectiveness of clean energy efforts, and halt most forms of transportation. Dust and sandstorms can have a negative effect on the climate, which can make desertification worse. Dew particles Dust particles in the air scatter incoming radiation from the sun. The dust can provide momentary coverage for the ground temperature, but the atmospheric temperature will increase. This can deform and shorten the lifetime of clouds, which can result in less rainfall. Next one, food security. Global food security is being threatened by desertification and overpopulation. The more the population grows, the more food that has to be grown. The agriculture business is being displaced from one country to another. For example, Europe on average imports of over 50% of the food. Meanwhile, 44% of agricultural land is located in dry lands and it supplies 60% of world's food production. Desertification is decreasing the amount of sustainable land for agricultural uses, but demands are continuously growing. In the near future, the demands will overcome the supply. The violent Rehada farmer conflicts in Nigeria, Sudan, Mali, and other countries in the Sahel region have been exacerbated by climate change, land degradation, and popular growth. And the next, vegetation patterning. As the desertification takes place, the landscape may progress through different stages and continuously transform in appearance. On gradually sloped terrain, classification can create increasingly larger empty spaces over a large strip of land, a phenomenon known as Brochet-Tigri. A mathematical model of this phenomenon proposed by C. Klaus Meyer attributes this patterning to dynamics in plant-water interaction. One outcome of this observation suggests an optimal planting strategy for agriculture in arid environments. Let's see the causes. The immediate cause is the loss of most vegetation. This is driven by a number of factors, alone or in combination, such as drought, climatic shifts, tillage for agriculture, overgrazing, and deforestation for fuel or construction materials. Vegetation plays a major role in determining the biological composition of a soil. Studies have shown that in many environments, the rate of erosion and runoff decreases exponentially with increased vegetation cover. Unprotected dry soil surface blow away with the wind or air washed away by flash floods, leaving infertile lower soil layers that break in the sun and become an unproductive hardpan. Many scientists think that one of the most common causes is overgrazing, too much consumption of vegetation by cattle or other livestock. Goats inside of a pen in North Chico, Chile, overgrazing of dry lands by poorly managed traditionally herding is one of the primary causes of desertification. INFIG, wildebeest in Masai Mara during the Great Migration. Overgrazing is not necessarily caused by nomadic grazers in large traveling and hard population. Let's see about reforestation. Reforestation gets at one of the root causes of desertification and is not just a treatment of the symptoms. Environmental organizations work in places where deforestation and desertification are contributing to extreme poverty. There, they focus primarily on educating the local population about the dangers of deforestation and sometimes employ them to grow seedlings, which they transfer to severely deforested areas around the rainy season. the Food and Agriculture Organization of the United Nations launching. Let's know about desert reclamation. As there are many different types of deserts, there are also different types of desert reclamation methodologies. An example for this is in salt flats in the Rab Al Khali Desert in Saudi Arabia. These salt flats are one of the most promising desert areas for seawater agriculture and could not revitalize it without the use of fresh water or much energy. Farmer managed natural regeneration is another technique that has produced successful results for desert reclamation. Since 1980, this method to reforest degraded landscape has been applied with some success in Niger. This simple and low-cost method has enabled farmers to regenerate some 30,000 square kilometers in Niger. The process involves enabling native sprouting pre-growth through selective pruning of shrub roots and the residue from prune trees can be used to provide mulching for fields, thus increasing soil water retention and reducing evaporation. Additionally, properly spaced and pruned trees can increase crop yields. The Humbo Assisted Regeneration Project, which uses FMNR, Ethiopia has received money from the World Bank Biocarbon Fund, which supports the sequester or conserve carbon in forest or agricultural ecosystems. Thank you.